easier to spot a lack of quality. So something that fails to meet the specification, that's poorly designed, very difficult to use, unreliable, particularly in sort of products, material products. The unreliability is very often equated with a lack of quality. So the way that quality then is achieved is by creating products from good quality materials and having a tightly controlled manufacturing process such that, and design process such that you're going to get the same sort of quality in all of the products that you build. Obviously in the information space the material is not quite so important in the sense, but we'll see what is important is the manufacturing process that we go through. The other thing about quality is that it's very much an open-ended quest for perfection, if you like. So the example which sort of immediately struck me was this one of music sets. So in the 1960s, 70s, there was this cult, of hi-fi, high-fidelity music systems. Okay, some of them were extremely good, but they were also extremely fragile. And compared to what had gone before in the 1940s and the 50s, they were obviously very, very good. But little bits of dust and so on would cause lots of noise on the system, and eventually they would wear out as well. The more you use them, the lower the sound quality went. So in comparison to the things that followed, the CD-ROMs and the MP3 players, the quality of those systems is quite low. And now we've got to the stage where the music quality is very high, consistently high, and the manufacturers are looking to other aspects in terms of reliability, battery life, ease of use, and so on. So it's a moving target, this is what I want to get across. So what we're trying to do is basically improve quality as time goes on. So the whole quality assurance business is basically about establishing a process whereby you can ensure that the quality of the system does get better over time. So what we've got initially is this system, product, service, and we've got some sort of vision or goal of what we want to achieve. And the idea is to instrument the system. So we can make measurements on that system in order to determine where we are at the moment, how close we are to meeting that goal. So we make the measurements, we compare them with the vision, what we're trying to achieve. We also compare them with what has gone before, the previous measurements that we made. Based on those measurements, we try to identify weaknesses in that particular system and implement changes to hopefully improve that. Then obviously repeat the measurements. If necessary, we may change the measurements themselves, although we prefer not to. And again, long term, we might even change the vision, the goal as well. Now, when it comes to information quality, there are some things which are reasonably obvious and consistent right across the spectrum. So the accessibility of the information, the coverage, does it include all of the relevant parts of the subject matter that we're interested in? Is it correct? Is it consistent? How up to date is it? And so on. So there's a number of common features to it. The real problem with information quality, I think, is that information is actually designed, and its purpose is to educate or to inform people. And therein lies the problem, because you write your wiki page or whatever, okay, your content, and you give it to the student or whatever, the reader, and you expect them to understand it. But as any educator knows, that's not the way it works, okay? You can't just sort of plop the information into the student's mind, okay? Sometimes it misses, okay? But even if it hits, it doesn't necessarily all get in, okay? Education is a much more complicated process in that respect. So the student has to be paying attention, he has to be motivated, and a lot depends on how much knowledge, background knowledge, what background knowledge they actually have already. So how does this new information actually sort of fit in with their current cognitive ideas? So the bottom line here is that basically what you write doesn't necessarily immediately turn into understanding on the reader's part. So the success of the information asset is very much dependent on the recipient, not so much on the actual material itself. I mean, both are necessary, but it's critically dependent on the reader, the recipient. So when we come to measure, or try and measure, how successful that piece of information is, the only person who knows, in a sense, is the person, the recipient himself. So in order to find that out, how successful it was, we've only got two choices as far as I can see. We can either observe the user's behaviour, either individually or in groups, after they're looking through this information, or we can explicitly ask them for their opinion on it. The problem there is clearly that not all users are equal. Some of them are experts, and then we have a range right down to novices, and unfortunately on the web we also have a number of subversive elements who either just take delight in messing things up, or explicitly for commercial reasons or something want to sort of convey the wrong impression. So the idea would be, in essence, we need to understand the user's expertise, and as a result of that, modulate their opinion. Whatever they say about our information resource, we need to vary their opinion based on their expertise. Again, we've got another problem though, in that on the web, you don't know who is who. There are thousands of people coming to your site, you don't know 99% of them. So we need to determine who's who and how expert they are. So basically, I'm not sure this is a particularly good diagram, but hopefully we can get the idea here, okay? So the user comes along, initially they were just viewing web pages, now they're creating web pages, creating content, updating content, and also we're asking them to rate the content, or we're asking them questions about the content to find out how good they think it is. Using that information, those interactions, we also want to create a model of the user. This is something which is commonly done in commercial systems in order to find user preferences to direct the right adverts towards them or something, or in educational systems where you want to get a model of the user, of the student, to decide what information to show them next, or what questions to ask, and so on. So the idea is to take the user interaction, get a model of that, and try and figure out how expert users they are, as well as get some information about the actual content and how good that is. And then combine those two to produce an assessment both of individual pieces of the contents of that system, and more importantly, an overall measure of the thing. So then we can identify weaknesses within the system and hopefully improve on them. So that's the idea. Update the content and user models using evidence gathered explicitly and implicitly from the users. Vary that assessment based on the system's understanding of the user's expertise. Clearly, everything depends on the user. On the users actually using the system, providing the feedback, and so on. So we need to encourage the users, therefore, make it easy for them to contribute to the system and to rate it. Obviously, Wikipedia has helped with the contribution side. The ratings now are becoming more and more easy to do with just dragging star things across. We can provide incentives for them to do it as well, and very important, I think, is that we show them the results of the evaluations they're making. One interesting thing was this ESP game. It's quite an old one now, but the idea was to produce labels for images. Very difficult, obviously, for the machine to do. So what was his name? Louis von Arn from Carnegie Mellon came up with this idea of human computation.